Hi everyone. Here's our tutorial session on how to make a line graph. Now this is a pretty good schematic representation of what a line graph looks like. Sometimes they go up and down like that, depending on the trend, or sometimes they just go straight up or straight down. Sometimes they're straight line and sometimes they're a curved line. Okay, but generally they look something like that. Okay, so what we're going to do is we're going to use information from an experiment on the growth of a bean plant. And if you take a look at this data table, you can see that it represents an experiment in which we grew a bean plant. And some plants were grown in the sunlight. That would have been the test group. And some plants were grown in the dark. This would have been the control group. And the idea would have been to find out whether growing in sunlight increases the length of the shoot. In other words, do plants grow better in sunlight than they do in the dark? Okay, so looking at the data table, the first column is always your manipulated variable. And the second column is always your responding variable. And you can see we have one responding variable here, which is our shoot length. We have some plants that were grown in sunlight. This would be our test group. And we have another set of plants that were grown in the dark. This would be our control group. Or negative control. Okay, so we need to be able to take this data and place it or use it to draw a line graph. So here's the steps on drawing a line graph. The first step is to determine which variable goes on which axis. And the manipulated variable always goes on the x-axis, and the responding variable always goes on the y-axis. So our x-axis is our horizontal axis. That's going to be our manipulated variable. Our responding variable is going to go on our y-axis or vertical axis. So the next thing we need to do is choose an appropriate scale for each axis and draw and label the scales. So let's do our x-axis first. Looking at the data, our manipulated variable is time, and the unit of time that we're working with is days. And we need a scale that goes from 0 to 12. So we need to put a scale from 0 to 12 along this axis. So what I'm going to do is just count the number of spaces I have. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19, 20. Okay, so we only have 20, so we don't have enough to make each 2 divisions worth 1 day. So what we're going to have to do is we're going to have to say each space between each line represents 1 day. We don't have to draw them all in. What I'm going to do here is I'm going to put in my 0 days. And then let's go up by 2. Okay, so now we need to label our x-axis, and our label or our unit sorry, our label is time, and our unit always goes in brackets. Our unit is days. Okay, so now we've dealt with our x-axis. Let's look at the data in order to figure out how long or how to scale our y-axis. So what we're looking at here is the minimum length, and you normally start with 0 unless otherwise indicated. We're looking for a maximum length. Maximum length is 16.7. So we need to get 0 to 16.7 on this scale. So it looks like, again, I'm going to have to make every division worth 1 centimeter. So I want it as big as I can on the scale. We're still using sort of even numbers. So if I made this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, yeah, 16, that's going to fit on the scale. So again, we normally don't label every single one because it just starts looking too messy. So I'm going to label the scale on every second space. And again, we start with 0 centimeters, 2, 4, 6, 8, 10, 12. Okay, it looks like that scale will work. Now again, you want to choose as big a scale as you can and still fit all your numbers on. Our maximum value here was in around 16. Our minimum was close to 0. But you don't want to work in multiples of 3. So you wouldn't want to make each one worth 3. Usually you don't make each one worth 4. So usually you make it worth 1 or sometimes 2. Like this could go 2, 4, 6, 8, 10. That works. Or if 1 and 2 doesn't work, then you normally go straight up to 5. So this would be 5, 10, 15, 20, 25. So we normally work in multiples of 1 or 2 or 5 or 10. And then it goes up from there. So 10, you might go every 20, every 50, every 100. Okay, but you normally don't use each division, make each division worth 3 or 4 or some odd number like that. Now we have to label our y-axis. So our y-axis was our responding variable, which is our length of our shoot. And our unit is centimeters. Okay, so for this one, this particular graph, we're also going to need a legend because we have 2 groups here. We have one set of data for our group that's grown in sunlight, our test group, and we have another set of data for our control group, which is grown in the dark. So we're going to have a legend on this one. So normally legend goes on the right-hand side, but I don't have any room here. So I'm going to put a legend here. And I will make my red dots and my red line my control group. And let me make my green line my test. Oh, I don't want to say test, actually. Let's put sunlight. You want to be as specific as you can. Oops. And you know what? That color's not working so well. It's too light. So I'm going to use a darker green. Okay. So there's my legend, L-E-N. Looks like you can spell length, doesn't it? Leggings. L-E-G-E-N-D. Legend. There we go. Okay, so now we're going to use the data to plot points. So our first data point is going to be at time equals 0 days and 1.2 centimeters of growth. So at 0 days, I have 1.2 centimeters of growth. So my first line in my sunlight group is going to be right about there, my first point. It's probably a bit high. That's better. Okay, and at time equal 2 days, it was 5.5 centimeters. And at 4 days, it was 10.8. So let's plot those 2 points. So I go to 2 days. So I'm going to go across my x-axis to 2 days, and then I go straight up until I get to 5.5 centimeters. So this is going to be 5.0. So 5.5 is going to be exactly there, halfway between the 5 and the 6. And my next one, 4 days, was 10.8. So at 4 days, I'm going to go over to 4, and I'm going to go up to 10. This would be 11, so I want it just below 11. So it's going to be about here, 10.8. And then 10 is 16.0 and 12 is 16. Oops, I missed one. Sorry, 6 is 13.3, 15.1. So I go across to my 6-day mark for the next data, and it's 13.3. So I go up 6 until we cross at 13.3. It's going to be about there. Eight was 15.1. So I'll go to 8 and then up to 15.1. 10 was 16.0. And 12 was 16.7. So about there. Okay, so here's our data points for our bean shoots that were grown in sunlight. Notice how they make quite a nice curve graph. So what we do next is we do a best fit curve, and this is sometimes difficult to do on the whiteboard. I'm just going to do my best here to get a nice straight line, but I'll just see how it goes. You have to go through the 0 point. Then you just want a smooth curve that best fits. It doesn't have to go exactly. Notice how I'm kind of missing that first point because it wouldn't make a nice curve if I went through there. All of the other points seem to be already on sort of a nice fit curve. Okay, so that would be our best fit curve. Now we could actually extrapolate. Notice how it's getting flatter and flatter, the curve. So if we were going to extrapolate, probably would almost start flattening out now. Just going to move that extrapolation line. Usually what you do is you usually do extrapolation lines with the dotted line. Something like that. So we could extrapolate to say 18 and 20 days and the growth we expected in 18, 20 days. Okay, so that's our curve for sunlight. I'm going to just do the same for dark. I'll do the couple of data points with you and then I'll turn it off and do the rest on my own here. Be really, really careful when you're filling in your data points. It's important to be accurate. So at 0 days, we're at 0.8 centimeters. At 2 days, we're at 3.3 centimeters. And this is going to be our red line according to our legend. So we're starting at 0.8. And day 2, we're at 3.3. So we'll cross to day 2 and up to this is 2, this is 3. So 3.3 is going to be about there. Now 4 days is 4.8, 6 is 5.5. So we're going across to 4 days and up to 4.8. So there's 5, so 4.8 is going to be about here. And then 6 was 5.5, over to 6 up to 5.5. 8, 6.2, 10, 6.4, 8, 6.2, 10, 6.4, a little bit lower, and 12 and 6.5. I'm going to change my 6.4 dot here. I made it a little bit too high. I normally do graphs in pencil. Okay, so again, we now have data points plotted on our graph. We're going to use a best fit curve again, going as nicely as we can through all of our points. But if the point, for instance, this one in our first curve is really not on the curve and it makes the curve not smooth, then we ignore it and we just go close to it. We take it into account, but we don't make sure we go through it. Okay, this data actually for our second curve is actually quite a nice curve. Oops. You get the idea there. I'm a little bit high. And again, better to do this in pencil. I'm just going to do a little black line here to show where that should have gone because I kind of messed up there. And again, we could extrapolate this on. Okay, so now our graph is almost finished. We labeled, we chose the scales, we put the correct label on the variable on the X and Y axis, the correct labels on the X axis and Y axis. We put the correct units in brackets, and remember our units, here's our labels, shoot length and time, and our units are centimeters for shoot length and days for time. We needed a legend, so we drew a legend. We plotted the data points. We drew our best fit curve, and now we have to write an appropriate title for our graph. An appropriate title is similar or identical usually to our title for our table. Now this title for our table isn't as descriptive as it should be. We really should say growth of a bean plant with and without sunlight. So you want to make a title fairly descriptive on a graph. Okay, so you can do it that way, or you can actually, and I'm going to give you an alternate title here, you can go back to your hypothesis and use that to help you with the title. Effect of sunlight on the growth of a bean plant. Okay, so the idea is to have quite a few words so that the title describes exactly what the reader is going to see when they look at your graph. Okay, that's everything for this lesson. Please use this information to go ahead and draw the graph that you're asked to draw in your lessons.